Hello everyone, welcome to section 5.2. Today we're going to take a deeper look into what a perpendicular bisector is, and specifically the perpendicular bisector theorem, a theorem that comes from the creation of perpendicular bisectors specifically on triangles. So what we're looking at today is this picture right here. Yesterday we talked a little bit about perpendicular bisectors and that if you drew all three of them, they would meet in a point called the circumcenter, and that the circumcenter was always going to be equidistant from the three vertexes of the triangle forming the circumcircle. Well, today we're going to take that a little bit further and explore that a little bit. The reason that works is because anytime you have a point that is on the perpendicular bisector, it's going to create a situation where that point is equidistant from the endpoint of the of the segment that the perpendicular bisector is bisecting. So for example, if I were to draw a point right here, this point is going to be equidistant from A as it is to B, which is the reason the circumcenter works the way it does that we talked about yesterday. If you find a point here that's equidistant from A and B, and then create the other perpendicular bisector and find a point on that line that's equidistant, and then find the perpendicular bisector of AC and find the third point that is equidistant from its two vertexes, from its two endpoints. Well, that point where all three of those lines cross is the single point that is equidistant from A, B, and C. Today, like I said, though, our goal is just to focus on one point and how we can explore this with just one single point. So, in example 1, it says find the value of x in the figure. This is going to be super simple in this case. What we know is that because this right here is creating the perpendicular bisector, we know these two values are going to be equal to each other. Those two side lengths are going to be equivalent to each other. So what I can do is I can take these two pieces and set them equal. And so the reason that's happening, again, the point that I'm choosing is right here. We can see that the perpendicular bisector goes through that point. Well, because that point is on the perpendicular bisector, it tells me that this side length to this endpoint and this side length to this endpoint has to be equidistant. All right, so we are gonna then know that these two have to be equal because they both go from this point to this point and this point to this point. So I'm gonna set the two equations equal. 7x plus 24 is equal to 13x minus 48. So I know here that I'm going to subtract the smallest of the two x's. So I'm going to subtract the 7x to keep things positive. Bring down my positive 24. 13x minus 7x is 6x. Bring down my negative 48. And now I have 6x minus 48, so I can go ahead and add 48 to the other side so that I can isolate that x by itself. 6x equals, I've got 12. I got 72. And divide both sides by 6, and I get 12 equals x, or x equals 12. And that does answer the question. It said find the value of x, so I'm good. I have answered my question. X is equivalent to 12. Oh, I'm sorry, that came off my screen a little bit. There you go. All right, over here in this one, again, the similar idea, but we're going the opposite direction this time. I've got this line here that is a perpendicular bisector. Sorry, actually, they do not tell me it's a perpendicular bisector, but we can use this going backwards. If this point is on this line and it is equidistant from this endpoint to this endpoint, because they're equidistant, I know that these two segments have to be equal. This has to be a perpendicular bisector. That's the only way that this would be equidistant as it is to here. So you can kind of pick up from that. Anytime you have an isosceles triangle, the perpendicular bisector is going to be the line that divides the triangle in half. So this is going to be a situation where we would set these two equal to each other as well. So you can see that that's kind of just the running theme here. Set the things equal to each other, and you're going to get your answer. All right, so I'll subtract 9x, subtract 9x. I end up with 8x. Bring down this negative 3. Over here, I bring down this positive 13 after canceling that. And then we'll move the 3 over so we can get 8x by itself. So I have 8x equals 16. Divide by 8, and I get x equals 2. Again, check that that is the answer they wanted. Yes, they said find the value of x, so we don't have to plug it back in. So that is a good answer. All right, coming down to these bottom two examples, example 3 and example 4. So similarly, these are asking us to do very, very similar questions. Here they've given me a perpendicular bisector. So we know that since point R is on that bisector, these two things have to be congruent to each other. So I'm going to set 7x minus 22 equal to 4x plus 5. And we're going to subtract 4x from both sides. 3x, bring down that negative 22. Cancel, bring down that 5. Add our 22 to both sides. I get 27, and when I divide by 3, I get x equals 9. This time, though, if you went ahead and boxed this answer in, you would not be right, because it does not say find x, it said find the length of RS. So I need to make sure that before I finish this question, I come over and finish the actual question. 4x plus 5, I'm going to plug in the 9 for my x. So 4x plus 5, replace the x with the 9. 4 times 9 is 36. And when I add that 5, I get 41 for my answer. The length of RS is 41. Again, the significance of this is that because this point is on the perpendicular bisector, it's equidistant from the other two segments. Any point that I choose on here would be equidistant. And again, that's why we can create a circumcenter or a circumcircle around the triangle using its perpendicular bisectors. All right, come over here to this last one. Yet again, I've got a line going through the triangle. This point is specifically on that line and is equidistant to E and F, so I know that this is a perpendicular bisector. And since this is a perpendicular bisector, I know that these two segments right here have to be congruent to each other, so I'm going to set them equal. That was annoying. Okay, so we'll go ahead and subtract our 2x from both sides. Bring down my positive 11, my 12x, bring down my negative 37. We'll add 37 to cancel out that negative 37. Over here I get 8 and 4, and I have 12x, divide by 12, and I get x equals 4. Yet again, if you were to go and box that in, you would be wrong because it doesn't say find x, it says find the length of EF. EF in this case is the whole thing, E to F. So you have a couple choices. You could add these two equations together and plug it into that. Get 16x minus 26 and add it into that. I'm going to do it this way, though. I'm just going to plug it into 2x plus 11. So I'm plugging into this equation, replacing x with 4. So I end up with 8 plus 11, which is 19. And because I know that this is equal to 19, I know that this piece is also equal to 19. So I can just take this and times it by 2 to get 38. And I know now that EF is equal to 38 units. So again, the main takeaway here is that anytime you have a point on a perpendicular bisector, we should identify that one of two things happens. It's going to make it so that these two sides are equal, or if you're given it, you're going to separate these into two equal pieces. But you can see that pretty much you just set things equal to each other. So you can use that idea to do all these types of problems. As always, let us know if you need any help. Thank you so much. Bye, everyone.